We're going to look at solving systems of equations today, not by graphing like we were looking at yesterday, but by using substitution and elimination, which are algebraic ways to be able to get the answers. Now, graphing works for the most part. If your answers were fractions, more likely you're only going to get estimates from graphing. Solving it with substitution or elimination allows you to be able to get the exact answer, whether the answers end up being nice, neat numbers, or fractions. Does not make a difference. This first one we're going to solve by substitution. So we're going to solve the first equation for x because there's a 1 in front of x. It makes it easier to use substitution. To get x by itself, you subtract a 4y. We're now going to replace x in the second equation with which we had right here, the negative 4y plus 26. So we're going to plug that in there. Still have our minus 5y and our minus 10. Well, we really don't need the parentheses, so we'll just drop them. So now we end up combining our y's together. They're on the same side, negative 9y. Subtract our 26 to get y by itself. Get rid of the negative 9 by dividing by negative 9. And we end up getting y to be 4. So now, let's go to this red equation right here. Plug in our y being 4. And it tells us then that our x is 10. So our answer then is the ordered pair of 10, 4. So we would know if we would graph these two lines, the two lines would cross at the point 10, 4. So now let's take a look at using elimination. When you're looking at elimination, you're trying to get the variables or numbers in front of your variables to be opposites. Whether you're trying to eliminate the x's or the y's does not necessarily make a difference. In this case, I'm going to choose to get rid of the x's because there's a 1 here in front of this x and a 2 here. We need them to be opposite. Well, if I just multiply the top equation by negative 2, it would be then a negative 2 in front of my x instead of a positive 2, which means it would be an opposite. One's positive 2, one's negative 2, they're opposites. So if I distribute the negative 2 through, and negative 2 also on the right side here, I get this. When you have the number in front of one of your variables to be opposites, you want to add your equations together. A negative 2x plus a 2x is 0. It drops out. Add your y's together. Add the numbers on the right-hand side together. Finish solving it for y. And we get y to be a negative 4. To finish this, all we're going to do is use some substitution. We're going to come up here, and we're going to replace y being 4 into either one of these equations. I chose the top equation. Put a 4 right here and solve it for x. You get a 12, subtract 12 from both sides, you get y to be, or x be negative 5. So x is negative 5, y is 4. In other words, you get the point of a negative 5, 4. We're going to choose to use elimination here. Here, in front of our x's, there's a negative 1, or I mean a positive 1. We need to have them to be opposite. So let's multiply one of the equations by negative 1. In this case, I chose to multiply the second equation by negative 1. So rewrite the first one, multiply the second one on both sides by negative 1. We get this. Since we have opposites in front of our x's, we're going to add. The x's drop. Add here, finish solving it for y, and we get y to be 4 again. Substitute y being 4 into one of your equations. Which one of the two you choose doesn't make a difference. I chose the top one. So you're going to get an x plus your y value of 4 equaling your 6. Subtract 4, and so now you get x to be 2 and your y to be 4, or the ordered pair of 2, 4. Here, we're going to go ahead and try to eliminate either the x's or the y's. In this case, you can't easily eliminate either one, so you got to actually multiply both equations by something. If you choose to eliminate the y's, and I'm choosing the y's because one's positive, one's negative. you got to think, okay, a 3 and a 2, what do they both go into? And in this case, it's a negative 6. So I'm going to try to get one to be a positive 6 and one to be a negative 6. To get my 3 to be a 6, I got to multiply the top equation by 2. To get the negative 2 to be a negative 6, because I want opposites, I got to multiply it by a 3. Distribute, and you got to do that on both sides, remember. Distribute through on the left side, your 2, and you get this. Distribute through by your 3, and you get this. Now that we have opposites in front of our y's, we're going to add the x's, add the y's, and add the normal numbers together. The y's drop out. Now we're going to have to divide by our 19, and we get 3. So we're going to go ahead and take our x being 3 and substitute it into one of the two original equations. In this case, I'm choosing the first equation. So you're going to go 2 times your 3 plus your 3y equals your 12. And so that's what we have here. We're now going to go ahead and finish solving that for y. So we get 6, because your 2 times 3 is 6. Subtract your 6, divide by your 3, and we get 2. So x is 3, y is 2, so you get the ordered pair of 3, 2. Remember, your ordered pairs are always x, y, or if you happen to be working with other letters in the alphabet, it's always alphabetical. This one here, whether you choose to eliminate the x's or the y's doesn't make a difference, but keep in mind the equations are not set up the same. Here you have x's followed by y followed by an equal sign. Here you have y's followed by x's, so you got to get them in the same order first. So if you rewrite the bottom one so the x's are first, sorry about that, we would have this. Now I'm going to choose to eliminate the x's, so I'm going to multiply the top one by a 2. When I do that, I get this. Notice the x's are opposite, and you'll notice also the y's are opposite. So you're going to add together this, add together this. In this case, you get 0 over here because everything drops out. Over here, you get a 3. Now, we know 0 does not equal 3. We have no variables left. 0 doesn't equal 3. It's a false statement, so there's no solution. Now, if all your variables drop out and you get a false statement, it's no solution. That's what the first one is talking about. However, if all your variables drop out and what you're left with is a true statement like 0 equals 0 or say 7 equals 7, then it's infinitely many solutions. When it's infinitely many solutions, remember, that's the two lines being the same line. If it's a false statement, that's no solution. That means the two lines, if you were to graph them, would be parallel lines.